Good day to you. This is Anagalactic bringing you the secrets of the universe. Over here you'll see a couple of diagrams from one of the world's most important science books, written about 250 years ago. The nature of Ruger Josip Bošković's Teoria Philosophie. It's not philosophy, but back 250 years ago that was the word that was used. This is not really mathematics. Mathematics underlies science. Mathematics has come to be identified with science. No, mathematics is a tool. It is not part of the Platonic idealist system. It's simply a tool. You really have to think about this deeply as you can. Now, mathematics really assists us. You can say that mathematics is part of science. We will be going into mathematical proofs. Proofs for what? Mathematics has a reputation that it simply cannot sustain, and we've known that for a century. So that introduces us to the Bošković Force Curve. You could say that technology has been on a
hyperbolic
rise, so that technology has gotten us into outer space, all the way to Mars, all the way to the outer planets. It was used by James Clerk in his formulation of EM, the most powerful discovery of all time. It is not really contested. Electroforce, magnetoforce conjugation, so that one cannot even exist without the other. That is so profound, but it's never talked about, it's never addressed. That there is electroforce, which is a force, which we very often call electricity. That is a manifestation of electroforce. And then you have magnetoforce. Both of these phenomena have a polar aspect, but they're perpendicular. They're perpendicular. And if you conjugate them, you get light. You get electromagnetic phenomena, which collectively is called light. We generally think of light as not being contained. That is, light is a free fall object called a photon, which is a free fall object anti-gravitationally. Specifically, it would not be called anti-gravity, but rather contragravity. It defies magnetoforce, because it's magnetoforce that holds the electron to the proton center. And that's a geometry that has a center. And that's our introduction to the Bošković Force Curve. This is the most in-depth science discussion you will ever engage in, talking about the conjugation of infinity. Thank you. We'll be right back. Over here, you will see two superimposed images of a curve. You can see that those are two separate curves. The top curve is a multiple curve. It goes both below the spaceline, that is the spaceline in this 2D projection, and it goes above the line, showing a change in force to its opposite force, one of which is repulsive, the other of which is attractive force. So this is the diagram of the closest approach of two particles before the particle had been discovered. You'll see there is one force curve there. The portion that I am pointing at now is the vertical asymptote, which is a relationship between a curve and a straight. And if you follow the curve over from left to right, which is going from origin at A, below the spaceline, where the force is maximal at the nadir, and then follow it to the right, it makes a second asymptote. So these are perpendicular asymptotes in this projection. This is the Bošković Force Curve. The electron-electron relationship also has an asymptotic curve that's entirely on one side of the spaceline, such that two electrons repel, and they repel forever, and they repel to infinitesimality, such that they cannot collide. And this has been proved. It is called the Pauli exclusion principle. It says explicitly that two electrons cannot occupy the same position. The interesting thing about saying that is it is a direct statement of the quantum paradox. And so you will be able to see the quantum paradox now geometrically by a simple projection using your internal visual perceptual system, which will be assisted by this curve. Picture two spheres, BBs. They are impenetrable. Are they? That is the question. If they're electrons, they're not exactly BBs, but they do have locality and must be thought of as spheres. Those are called particles. This is a very specific kind of particle called an electron. If they are forced together by applying relative velocity to one at the other, they will not collide. So they are impenetrable to each other. They will not occupy the same position in space. Therefore, they do have a radius. They have a spatial presence, which is quite interesting, because if they have a spatial presence, what's inside? So it has a surface. I did not discover that, but I made a geometry for it that has been literally staring us in the face for over 2,500 years. An intrinsic geometry, which means the geometry of surfaces. As a surface that cannot be penetrated. Cannot be penetrated by what? Another particle. Bošković addressed directly. His direct predecessor, Newton, was alive when Bošković was born. They never met because they were separated by a generation, you could put it here. Now, what does that have to do with this force curve, so we can get onto our topic and close this video out in just 10 minutes in order to get into the geometry and finally the mathematics, all of which Bošković covered, but using the tools of his day. I discovered a new tool that is more powerful than the calculus. Calculus is a rather strange and in some ways deceptive tool, which has been blown enormously out of proportion in its relative importance to science because of the rise of technology and the desire of governments to penetrate outer space, all of which requires calculus. It's not exactly a cheat, but the overhead imposed by this algebraic tool is so crippling to humanity that it can only be called an unmitigated curse. Millions of children are forced onto a vector that has calculus very soon in the development of that human being. Calculus will destroy you unless you're worldly. In these closing 20 seconds here, I want to introduce to you the Bošković Force Curve, which we're going to treat in its simplest form. We won't be talking about the multiple curves, which is, the Bošković Force Curve is multiple curves because that describes the Bohr atom with any number of protons. We'll be right back. Thank you very much.